Hello all. In this video, we are going to learn about the memory of 8086 microprocessor. So, minimum mode of 8086 microprocessor we are going to learn, and this is the architecture of 8086 processor. We have clock generation device, ready signal, reset signal, uh, then data transfer, read. When R bar is 1, then it's like writing signal. When it is 0, then it is reading signal. So BHE, arithmetic logical operations, will be performed by means of ALE, latches for storing the data for temporary data storage, random access memory. We have EEPROM, we have electrically programmable read-only memory. Input output device, we have VCC, which is nothing but the power supply. Memory, input output devices, signals, we have address bus to transfer the address data, uh, data bus to transfer the data related information. Say for example, if we have address 4500, then that address will be transferred through address bus, and the data or the input which we have inside 4500 will be transferring through the ad- uh, through the data bus. So address bus for address and data bus is for data. So we have the we have the clock timing diagram, clock signal, timer T1 and T2, arithmetic logical operations, and read operations, data enable read and write operations. And this is nothing but the timing cycle, timing diagram. So here we have the maximum mode of 8086 processor, the reset, hold signals, hold acknowledgements. Whenever the signal is holded, we will be getting the acknowledgement to HLDA, hold acknowledgement, interrupt signal. Say, for example, if we want to connect another device or a keyboard or a output device or a display device or some control system with this microprocessor, means then that interrupt has to be connected through INTR, interrupt signal. And once after connecting the interrupt device with the 8086 processor, we will be getting the acknowledgement through INTA, interrupt acknowledgement. So the address bus and data buses are like AD0, AD15, and address bus status signals will be there. The read signal RD bar, write signal is nothing but WR bar. Data enable, when the device is ready signal will be enabled. Clock signal is there, and reset is for refreshing the device. Maximum mode 8086 processor system, is the one which we have seen in the previous diagram, very first slide of this video. So maximum mode 8086 system, uh, it is nothing but a numeric coprocessor of the type 8087 or another processor which is interfaced with 8086 microcontroller and microprocessor. The memory bus, address bus, data buses are shared resources between the two processes. So it's like inbuilt latches and buses and memories are inbuilt in the processor itself. That is what mentioned here. The control signals for maximum mode of operation are generated by the bus controller chip 8788. The three status outputs are nothing but S0, S1, and S2 from the processors are given as the input to 8788. The output of the bus controller are the control signals, namely data enable, data transfer, data receive, IORC, and these are the control signals which will be providing information to the microprocessor. This is again the timing diagram of maximum mode, and so we have three status signals S0, S1, and S2. So this is like the binary information: 000, 001, 010, 011, 100, 101. 110 and 111. So for each status, 000 means it's like input acknowledgement. 001 means it's like input read. 010 means input write. 011 is the halt. 100 is opcode fetch. 101 is memory read. 110 is memory write. 111 is nothing but passive or the halt. So I hope you would have learned few things about 8086 microprocessor in this video. See you in the next video. Until then, it's bye from Radhika.